Hey, everybody. Welcome. This is Justin Rosenberg. Just wait a few minutes and then we'll be ready to go. So we got going serverless with AWS Lambda with Andrew. And let's go through the slides. We're going to welcome the Kansas Java user group and also the Kansas Java AWS group for joining us. I'd like to thank our sponsors, IBM and VMware Tanzu and YRC Freight. And Java News of the Month. So Java has Java 15 release is anticipated in September, and it has a new feature, Unicode 13.0 support for all you Unicode freaks, improvements to the tree map, but my favorite is the text box, pre-formatted strings. It's a long time that Java hasn't had it, and it's coming to Java with this release. And there's an example with HTML, but you can also have example with JSON. It'll really make strings more readable, more copyable, and just great. One thing that's removed in Java 15 is Nashorn JavaScript engine, APIs and tooling. That makes me kind of sad because I have a little application written in Nashorn, but it's going away. And also DocuSign or Kamado root CAs are being removed. Releases. So we have Gradle 6.6 and Kotlin 1.4 is being released. Micronaut 2.01 and Quarkus 1.70. And in other news, we have Spring 1, which is September 2nd through 3rd, Everything Spring platform. And JConf Dev, September 30th with Everything Java. And J4K, which is Java and Kubernetes, is October 13th through 14th. Kansas City Jug, September 10th, featuring Venkat Subramanian, his continuations, and Fibers, the new frontier of Java. Lightning Rounds is October 15th, and Lightning Rounds where we look for the community to give like 5-minute talks to kind of strengthen their public speaking skills, and we want you to go to sign up there. The form to sign up is there, and you can talk. Anything we missed? To get involved in everything, to get involved in Java user groups, you can attend meetups, tell friends, you can like and subscribe to our YouTube channel, suggest topics, speakers, and locations, volunteer to speak at papercall.io KCJug, or follow us on Twitter at KCJug, or provide general feedback at the Google form down there. All right. So I will invite Andrew, and he'll be speaking today. So Andrew, how are you doing?
Hi, how's it going, everybody? My name is Andrew Rubalcaba. Thanks a lot for having me back on. I know I presented about a month or two, about 2-3 months ago, and it was the same talk, but we had a little bit of issues and problems, so really gave me the opportunity to come back and present for you guys again. So I'm going to go ahead and share my screen. So this might be kind of tricky because I've got two monitors. I have like this huge, like 34 wide monitor, and things might look a little weird. So if something doesn't look right, please just somebody let me know, either put a comment or something. But I'm going to go ahead and get started. All right. Can you guys see my screen? Awesome. So going serverless with AWS Lambda. Go ahead and get started. A little bit about me. I'm a Java Spring developer here in DFW area. I'm also on the Java Mug board. You'll see me tweet every now and then on Twitter. My handle is Han_Cholo. If you have any feedback or just want to talk about anything, Java, serverless, whatever, just go ahead and shoot me a message. I tend to be pretty good about responding on there as well. And that picture of me is my wife and I went out to Turkey a while back and trying to be super touristy, and I wanted to take a picture looking like the Sultan. So what does serverless mean? I like this tweet by Kelsey Hightower, who says serverless because cloud native EJBs doesn't sound as cool. And being an EJB developer early on in my career, that one just hit hard. So I wanted to include it in my talk. So let's talk about serverless. What are some serverless traits in order for something to be serverless? No managements of server host or server processes are required. Auto scaling just happens, based on load. You don't have to worry about anything about auto scaling your services or anything like that. And then, of course, my favorite part, and I think it's one of the main reasons it's kind of taken off, is cost is based on usage, right? You're only paying for when you use it, and when you're not using it, you're not paying for it. And I'll get a little bit more into cost and pricing as we go on throughout the talk. And then performance capabilities are different in terms of, it's not based on host size or count, right? Not like your EC2 instances, right? You have several EC2 sizes, EC2 instances based on computing, memory, whatever your use case might be. The performance capability for serverless things aren't defined in that. And then, of course, it has implicit high availability. And I also included this definition from Paul Johnson, scale to zero, right? My definition of serverless is an economic one, is an application that costs you nothing to run when nobody's using it, excluding data storage cost. And again, I think that's one of the biggest selling points as to why serverless, in my opinion, it's why it's taken off and why I think it's going to be a big part of the future, because everybody loves to save money. Of course, wanted to talk about how we got here, right? How do we get here? How did we go from all these servers to serverless, right? And what we end up with is this progression where we started over in the data center, right? Everybody would set up these machines. You'd have to kind of more or less anticipate what your traffic would be, and then you'd go through the whole process of procuring yourself a server, getting it set up in your data center. And of course, all that was a pain, right? Because you had to pay, there's several costs involved in there, right? You had to pay for the facility, you had to pay for the servers, you had to pay for the electricity costs. There were so many costs involved in getting your data center set up. And then somewhere along the way, last couple of years, Amazon released these things called the EC2 instance. And you no longer had to go through that process, right? Amazon kind of handled all that for you. All you had to do was set up and configure your machine, and you still have to manage it, but where that server is housed is none of your concern. Where, as far as like the electricity costs, all those other things, and it gave you the ability to spin up instances as fast as you needed them, and at the same time, if you didn't need them, you could go ahead and just spin them down. And so there was definitely cost benefits in there, right? And then, of course, as time went on and more people use it, you get the economy of scale, right? As the services scale, the costs start going down for you. And so it's pretty great. And then we start going up that abstraction ladder, right? We get into Docker containers, which have blown up in the last couple of years, right? You have a whole bunch of companies that have adopted Docker. And I should have included it here, but I think the same thing goes around in this area with Docker when we talk about platform as a service, right? It's just another level of abstraction. And I was pretty bullish on technologies like Cloud Foundry, Heroku, and I really thought those things were going to take off in a bigger fashion than what they actually ended up being. But what actually ended up happening, I think, is a lot of companies built their own platform as a service using technologies like Docker and Kubernetes and so forth, right? And Lambda is just a progression of that, right? It's just a higher level up in that abstraction, and us not having to worry about the containers and not having to worry about the Kubernetes aspects and so forth, right? So why AWS Lambda, right? One is pricing, speed to market, and scales automatically as we need it. We'll get into more about that. Again, I talk about pricing, but just to give you an overview, if you're using Lambda, upfront, AWS gives you 1 million free requests per month. And then if you get more than 1 million, per million requests, that costs you 20 cents. So it ends up being pretty cheap. And then, of course, based on how much memory, we'll get into that a little bit more. But the more memory you use, obviously, the more it's gonna cost you a little bit more. But we can get into that more here in a minute. Just real quick, going over the languages that Lambda supports, right? We support Java, Java 11, Java 8. It's using the Open JDK. And here recently, they allowed you to use the Amazon JDK, the Corrado, I think is how you say it. You also have Node.js, Python, Go, .NET, and of course the interesting aspect is, and I'll talk about this here in a minute as well, is you can bring your own. They have the concept of what you call custom runtimes, and that plays into some other pieces that I'll cover here in a minute. Some excellent use cases for serverless and Lambda type of technologies, right? Is you can run serverless web applications, you can run IoT applications, you can run Alexa, chatbots, data processing. There's all types of great use cases that you can use with Lambda and serverless technologies. And then under the hood, this is basically what it looks like, right? You have code that you upload to Amazon, and then what triggers these are these events, right? The events that could be a command from a CLI, it could be something coming in from an API, it could be a trigger of some sort. You can have some of your AWS services, and I'll talk about some of those that are actual event sources that when something happens, a change in state somewhere causes these triggers to be fired off and in turn call your Lambda. And so what's actually happening under the hood is pretty complex, but basically what's happening is an event comes in for your code, right? And for the code to be executed, it has to download your code, and basically underneath the hood, it's spinning up a container for your code and loading up the JVM, loading up your code, and then executing the actual code that you're running. And so that's why that initial part, you'll hear people talk, and I'll be mentioning it here in a minute, but the concept of cold starts, right? The first time your function is invoked, it's going to take a little bit of time, a couple milliseconds, should be milliseconds, but could be seconds and so forth. But it takes a while for it to load your code, get it all set up, and then executing and returning the response. And in fact, when I run through my examples, you'll see that it's going to take a couple seconds because my Lambdas aren't what you call in a hot state, right? They're not warm. They're not warmed up. They've been sitting out there for a while, and then I'm going to invoke them, and it's going to take them a while. But then after that, if you keep hitting the API or you keep hitting your Lambda functions, you're going to, that function will stay warm. And then again, if you're not using it, just get spun down. And again, that's where your cost savings comes. You're not using it, so you're not being charged for it. And then somebody else comes back in, some other event decides to call it, goes back through the same process and so forth. And this is basically what the code looks like. You have a couple of handlers that your code extends, and I'll show you some of the code here in a minute, but you really don't have, like before most of your Java stuff, you have some kind of entry point, whether it's your main function. But here it could be any kind of function. And most of the times, it's this, you use a request handler type of interface, extend it, and then you override it, and you can pass whatever information that you need. And I'll walk through some of that here in a minute. But it's pretty simple, and it's just, a simple function. That's the function that then gets executed. I'll show you here in a minute. I want to talk about just real quick the context object, which is just a context object is what you saw get passed over here. And that has some useful information about the environment that you're in, and you can use it to get things such as your logger. You can use it to maybe troubleshoot something. There's all kinds of information that you can pull from your context, but the Amazon documentation kind of goes over a lot of the stuff that you can pull and use the actual context for. And of course, just logging. You can use hooks into CloudWatch, and you can use most of your logging libraries like Log4j, Logback, and so forth. Let me go ahead, and give me a minute. I'm gonna load up one of my services so that I can show you one of the simple lambdas that I have. Give me a minute. I have just real quick. But I have this Lambda function. Let me see here.
Hey, I got a question for you.
Yeah, go for it.
Is there a configurable TTL for spin up down?
A configurable
time to live.
Oh yeah, the time to live. There's not a configurable time to live, but what you can do is, I think by default it goes like 4 or 5 minutes. But there's not a configurable way for you to say, I totally get what you're saying. Like you say, I want this to be alive for a certain amount of time. But there's a concept of something called provision concurrency, and you can basically set it up to be in a way kind of like the configurable TTL, I guess. But you can say like, I always want an instance of this Lambda running or so forth, right, for this amount of time. Or you can say, if you know that your busy time of the day is going to be from this time to this time, you can have the provision concurrency be there so that there's always a warm instance there for you. The bad thing about that is that you do incur a certain cost, but hey, maybe it's a cost that you're willing to incur to keep your services going. Great question. I'm gonna load up my sorry, doing one of my hello functions. Can you guys? Oh man, sorry, just take me a while. Just want to make sure. Oh, awesome. Yes. So this is what the function looks like, right? This is just a simple function that I created.
Sorry. Can you zoom in a little bit?
Yeah. Can you guys see that?
Awesome, thanks.
Yeah. So again, this is just a simple function that I created, and I'm saying, hola gente de KC Jug. And I'm building some kind of response here, and I'm sending back a 200. And if I come in here and I invoke it, let's see here, test, I should get a result that comes back. I get the response, and it comes back as this JSON object, and I see that I got my hello KC Jug. Of course, that's not real exciting, but you always got to do the hello world. And I figured I'd show you that early on. So I'll come back to some more demos, but I wanted to talk a little bit more about some things. So I noticed, Justin, you brought it up at the beginning of this thing, right? You brought up the Quarkus news, was it 1.7 and 2.0.1 for Micronaut? And those frameworks are actually really great frameworks that you can use. And a lot of them were made to be run in this type of scenario. And they're great for the Lambda type of experience. For the main reason is that they're supposed to speed up your start time so that those cold starts are a lot smaller, right? It's not taking up so much time and so forth. And I started seeing that pop up a couple months ago, or around the time the Lambda stuff started coming out. But I started to see a lot of interest, and people were asking like, oh, well, what is the especially with some of these frameworks who were saying, oh, but the start time on this is really, really fast. And I remember thinking like, why would that be really important, right? My Spring Boot applications boot up pretty fast. It's not a big deal for me, but it's not a big deal for me because I'm running in an application server environment, right? And that is really not a big factor for me. But if I'm in a setting like on AWS Lambda and I do have, a considerable start time and, it could take a couple of seconds, that's going to be a performance hit and somebody else could notice that. And so that's why frameworks like Quarkus and Micronaut make it to where you can spin up these Lambdas pretty fast. There's great examples of that. I think I want to do a part 2 to one of my talks, to this talk, where I follow up and doing a lot more examples, diving into Quarkus and Micronaut. But it's outside of the scope of this talk, but I definitely wanted to cover it. And then this AWS serverless Java container piece is actually created by an individual on the AWS side. And I think the underlying use case for this is pretty interesting because, you'll hear a lot of people say, well, you don't want to do heavy duty type of things like Spring and so forth in a Lambda type of setting because you have all these dependencies you got to bring in that could increase the size of your jar, which causes issues. It could increase your start time and so forth. And there's all these reasons, right? And best practices, people will say like, don't do it that way. That's not the way Lambda was meant to be used, especially with Java. But I do think that it's a great way to maybe get you there eventually, and then you can start to break it up and start. In other words, you could move pieces of your application to Lambda using something like the Java container and create your small entry points. And though it might take a while for it to start up and everything, but it gives you an idea of what you can and can't do in that environment. And I think there's a great podcast I was listening to a while back. I'm trying to remember the guy's name, but he did something similar with a Ruby on Rails application. And he took like a big Ruby on Rails application and he created this framework called Lambda, which runs in AWS Lambda and allows you to run all your Ruby on Rails type of code in a Ruby on Rails type of way. And everybody was like, why would you do that? But he was like, hey, it fit my use case. It works for me. And once I got there, I started to break down the application and making it more what I would say is a serverless native type of approach. And it could be the gateway drug that gets you there, right? Eventually get buy-in.
Hey, I got a question for you. This one comes from Bill Dinger. The handler contract, is the handler contract defined by AWS?
It's defined by AWS, but there are the aspects in the generics that you can override. So if you look at the documentation, I don't have it on me, but you have the request handler, which is the actual interface, but then you saw those pieces. Let me see here. Sorry, I'm pulling up the code. Like these aspects of the interface, like these generics, you can definitely override. What goes in here is pretty much up to you, but they do define the actual interface. Good question.
And I got another question for you. Says deploying Spring Boot apps and no? Or yes.
Yeah. So again, it's one of those things like it really wouldn't make sense depending on the size of your application because it could be too big, right? Depending on the size, like you have some limitations that I'll cover here in a minute, but the size of the jar, like jars can't be bigger than a certain size. And also the aspect of the cold starts, right? If you have a Spring Boot app that wires a whole bunch of dependencies when it starts up, it could eat into that cold start time and it might not be the best approach. But I say that, but if you can get it to work and use something like the AWS serverless Java container, man, by all means do it. I would do it to get there, and then, like I said, break up the pieces and make it more serverless native approach. And there's great blogs that cover that allow you to take a Spring Boot controller type of approach and put it out there as a Lambda. And the Quarkus project, I'm not sure about the Micronaut. I know for sure the Quarkus project lets you use a lot of those Spring annotations, and you can make it in a very Spring Boot type of way, and the startup time would be fast. So if you're definitely looking into doing that, I would definitely look into the Quarkus project. And of course, let's talk about some of the AWS services that scale well in a serverless world, right? Serverless Mundo. Right, you have some of these services that you guys might be familiar with, but this simple queue service, which is one of the first services that AWS came out with, but it's a simple queue service, and you have your first in first out queues, and it's great. It's great if you want to use it for function-to-function communication, and it's got a bunch of great use cases. But basically, you can use SQS as an event source, right? And something comes into that queue, and it fires an event to your Lambda. And so forth. But there's lots of great use cases for this. The simple notification service, another one, pops up, broadcast events, same type of scenario. You can use it as an event source. It scales really well. And a lot of these are great because you're only paying for what you're using, right? If you're not using SQS, I mean, if there's no messages in there being processed, you're not paying anything for it. It's just sitting there, but something comes in, yeah, that's the aspect you pay for it. Kinesis is another great one, which I'm sure there's a lot of developers on here familiar with. Something like Apache Kafka. Kinesis is very similar to Apache Kafka, and same thing. It could act as an event source, and you can use it to build. In fact, there's a lot of people that use Kinesis to build data pipeline processors using Kinesis and Lambda. Of course, if you get started and you started on some of these tutorials, you're going to run into the famous image thumbnail application, where you drop an image into S3. S3 then fires off an event to a Lambda, and it resizes that image and maybe creates a thumbnail for you. There's lots of great use cases. Same thing for S3, storing things in there. I don't know if you guys have ever heard of A Cloud Guru, but one of the things that they have is they'll drop these videos into S3. And once it falls into that bucket, events get fired off to different Lambdas to do different things, or different processes get fired off to do transcoding and do all kinds of things with that video to process it for their platform. In fact, I think that's one of the biggest things about A Cloud Guru is their whole platform is set up to run in a serverless approach. They don't have any actual servers that they manage. And DynamoDB is another, which is the AWS NoSQL, one of the NoSQL offerings that they have. And again, it's really great because it has HTTP endpoints. It's got transaction support. DynamoDB is kind of like the preferred data store for Lambda type of architectures. Relational databases have issues, although Amazon is coming up with ways to work around some of those issues. But one of the big reasons that relational databases are an issue is because you run into the problem where you could have thousands of Lambdas spin up, and each one of those creates a connection to your database. Well, you're going to run into issues with your connection, right? Because you don't have the concept of being like an application server and having a data pool to use all those connections, right? To make the connection handling a lot more efficient. So you end up running into issues. And so one of the things that AWS has come up with is they have a relational database offering called Aurora that has a serverless API for it that they're using, but that's a little bit more expensive. And they also have, I think it just went live, like GA is a product called RDS Proxy, which again makes it okay and feasible for you to use a relational database. But most of the examples that you'll see out there, most people tend to like to use DynamoDB. I will say this though, that DynamoDB has a bit of a learning curve, mainly because you have to learn how to model your data a little bit differently than you would in a relational way. But I mean, that's almost any tool out there. And of course, the most famous one is this API gateway, which is makes it easy for you to manage all your to use your AWS Lambdas in a restful way. And I'll show a demo of that here in a minute. And of course, this is the one I was talking about. Lambda, it's a function as a service, event driven, scales automatically, and you pay per use. Some of the development tools and frameworks for developing, AWS has their own called AWS SAM Serverless Application Model. And the one I'll be using today is called the Serverless Framework. I think that they were one of the first people to come out with the tool out there. So that was one of the big hurdles that early on came about when Lambda came about, is there weren't a lot of tools or frameworks that help you in the development process, especially for developing, deploying, and getting your code out onto AWS. There's this other one called Stackery, but as time has gone on, these tools have been improved upon, and they come a long way. The serverless framework for itself has a lot of plugins that you can use. I'll talk a little bit more about those here in a minute, but they're all great. I mean, these three are pretty great products, and there's tons of other ones out there. Like I said, the one I'm using today is called the Serverless Framework. It's widely used by all serverless developers. It's got a great plugin ecosystem. It's got this concept of like templates where you can spin up projects pretty easily with everything kind of scaffolded out and just ready for you to start developing on your business logic. And you behind the scenes, it's pretty interesting, but it's using cloud formations, and it uses a cloud formation to put out to AWS and create all the resources that you're going to need for your application. So, and I'll show you this, but it's got a YAML configuration, and you configure a lot of the pieces for your application within that YAML file. And it's pretty straightforward. And then behind the scenes, like I said, it's using CloudFormation to push out all your code and create all the resources that your code is going to need to run the application. So it's pretty neat. The Pro offering does have a great CI/CD for continuous integration, continuous deliveries, and metrics. And like I said, of course, there's great templates. I mean, there's templates for Scala. There's templates for Kotlin. For most of the projects out there, there's like great templates that you can use, and they help you get started pretty quick. And all I did for mine was, that's what it looked like. Man, it cut off that Java piece. It does. But I created like a quick serverless project. I'd use the template, the Java, if you can see there, the AWS Java Maven template. I created a tacos API because I love tacos. Being from Texas, tacos are like a big thing down here. And I called it, I gave it these parameters, and it spins up a project, and then that project ends up looking like, I'll show it to you here in a minute. But I'm going to be using Java's serverless framework. I'll come back to it here in a minute. But I do want to cover that there's some bad use cases for Lambda. It's not the end all be all, and I don't recommend it for every single thing out there. It's not great for long running processes, right? Because it has an actual cutoff time. I think a process can't run more than, I'll try to look at the documentation. I can't remember off the top of my head, but long running processes aren't great. It's going to charge you a lot. And after a while, the service just kind of spins down. If latency issues are a big problem for you, I know this has been a big thing for a lot of people, especially when they're behind like VPCs. There's like certain latency issues. It might not be a great use case for that, but it is great. Again, if you're doing something like an async processing, some kind of file processing in the background, you don't need that in real time. It's great for that. Again, current monolith applications are not the best use case. You don't want to move a whole giant monolith application into a Lambda setting. It's not going to be a great experience. And here are some of the limitations that you do have. You have 1,000 1,000 concurrent executions can run at a time. This is a soft limit. If you need more than that, you can open up a ticket with AWS and they'll increase, behind the scenes, they'll increase the count for you. 128 megabytes to 3 gigs are the limits that you can give per function. Although this, to me, is always increasing as I think they see fit. I think when they started out, I think the most you could go up to was like a gig, and now it's at 3 gigs. So you can give your Lambda function as much as 128 to 3 gigs of memory per function. And this is what I was talking about, that 15-minute, it's a 15-minute timeout. So again, if you're gonna have a long-running process that takes more than 15 minutes, Lambda is not the ideal solution for you. And in fact, I have a buddy of mine who works at a startup here in DFW, and that's one of the things that they do. They do use some Lambda, and then they have some microservices that are not Lambda. There's something in like Docker. And so the delineation that they say, if something's gonna be a long-running process, they don't run that in a Lambda setting. They use some, some kind of container or something else. You have a 6 megabyte on a synchronous payload, and then 256 kilobyte on an asynchronous payload. And then your deployment package, the biggest it can be is 50 megabytes if you zip it up, and then 250 megabytes on zip. So you do have some limitations on the file package size. Again, a lot of these, as more and more people use it and customers make requests at AWS, they keep bumping these up and increasing it. So I do think most of these are eventually just going to keep going up. Again, beware of cold starts. Cold starts are definitely an issue. You need to be aware of that. And again, there's several ways you can minimize that. Beware of long-running processes. Again, like as I mentioned, the relational database aspect is, you just need to be aware. Like, it's not to say that you can't use it. It's just you need to be aware, because you could potentially like just starve out all those connections or have tons of connections and make that end up crashing your whole relational database. Function-to-function communication is kind of considered like a big no-no. You're not really supposed to do that. And like I said, there's definitely other services that you can use for function communication, something like SQS or SNS or any of those other services that I talked about. And again, obviously the big thing is lock-in, right? If lock-in is a big concern for you, you are gonna be locked into to an extent if you go with AWS Lambda. But I think, to me, the speed to market that you get is worth it, and it's not a big deal for me. But I know there's people that are like, nope, I don't want any kind of lock-in or any kind of dependence on AWS for that. Everybody has different preferences. Just wanted to call it out. This is a diagram of what your architecture would look like in a serverless type of application settings, but you could even have something as your front end being serverless, right? Sitting something on, in fact, the demo that I'm going to show is something that's sitting on S3, right? And what you could do is you could set up something on S3, have it with a CloudFront, have it fronted with a CloudFront CDN, right? Everything comes through HTTPS. It's global CDN on Amazon's global CDN. And then you can have your applications run on that, some of your, maybe like React or Vue.js or Angular or whatever, right? But the front end part could run on S3 or whatever server, anything else. But then as it gets in, right, you make requests through this API gateway, and it goes into your Lambdas, goes into, talks to DynamoDB as your data store. That, in fact, acts as another event source, publishing more events to another Lambda that then pushes something out to SNS, sends out an email to your customers. You could also have things pushed from CloudWatch into this Lambda, pushed out into some kind of other data source that you want to pull reports from, and so forth. You can do all kinds of awesome things, but you can start to abstract some of those pieces of your application out into some of these services, right? And one of the things that I like about it is, a lot of times you'll see these diagrams and they look pretty complex because there's several moving pieces, right? But somebody said, well, you technically have those pieces a lot of times within your application, But what you're doing now is you're moving that complexity out of your application and onto the actual architecture itself and letting some of these services handle it for you. And they're great, right? Especially like SQS, right? Something like messaging. At my company, we use SQS for everything, for messaging. And before, we would have to set up some kind of MQ server, whether back in the day, it was IBM, or here recently it was RabbitMQ, but now we could just set up a SQS, publish our messages to that, and we don't have to worry about managing any of that stuff ourselves. This is what the architecture again would look like for something like an IoT type of architecture. You can use GraphQL, you can use all kinds of things, but again, just basically a whole bunch of events triggering your Lambdas, doing something with that information. You can have an IoT, some kind of sensor that publishes events to a gateway that go into your Lambda, so forth. Just another diagram. All right, time for the demo. Real quick, I'm gonna pull in one of my. I was gonna pull in because I wanted to talk about this this code. I'll increase it here in a minute. Give me a second. But this is that project that I used with the serverless project that you saw me earlier in the slide. And I wanted to call attention to a couple pieces in here. Obviously, this is what I was talking about earlier, is this, here, let's increase it. This serverless configuration, the serverless YAML, a lot of the information in here is basically what's going to drive what gets pushed out when I do a serverless deploy of my application. But I have the name of the service. I have the provider. So if you see here, I'm using AWS, but Serverless Framework actually works with other serverless other functions as a service implementations out there, such as Azure functions, and I think it also does some of the Google functions. I'm telling it the runtime, the stage that I'm doing it. If I want to do, I can do various stages, but here I'm just doing dev, the actual region, and then some of the some of the IIM roles and so forth. Again, this is a demo. You probably want to make your IAM roles a little bit more granular. Mine, I just kind of give them the star function so that they can go ahead and do everything. But you probably want to give your Lambdas as much permission as they need, and nothing more and nothing less, right? Because you don't want them wreaking havoc throughout your environment and so forth. This is where I start to actually list out my functions, right? I have a list, like my description, what the handler is that takes care of this, that fulfills the requirement for this specific function. The events in this case, the event is an HTTP, increase it. HTTP event, the path that I'm going to use to get there, the method type, because of the course thing, I had to do some course configuration. I have an actual get product. I have an actual create. I could have called these anything else. I called them create products, but I could have called it a create taco. The handler for creating a taco, what that path is going to look like, the method that is actually going to be used, the HTTP method that I'm going to be used to invoke this, and some of the more course heading. Some of the resources that I'm going to use, I did my DynamoDB configuration within this within the serverless YAML configuration as well. And I'm giving these like some simple settings. These can get pretty tricky, and you kind of have to, again, the DynamoDB stuff it's a little complex because you have to sometimes come up with the read-write capacity for it, and it's kind of tricky to come up with that, and you have to play around with it a little bit for the demo's sake. I just gave it some simple settings and so forth. And the table that it's going to go to, this tacos table, and so forth, right? And the actual code, right, to actually like list out the tacos. This is what, it's pretty simple, but I'm basically using DynamoDB to query for my tacos to get my taco list. I get this list of actual taco products, and I then go ahead and create the JSON and so forth and build the response and send it back to the client. Same thing for getting a specific taco.
Don't forget to zoom in the code, please.
Oh, sorry. Yep. So here I'm actually getting a specific taco, and I'm looking for path parameters to get, and I'm looking for the ID, and I'm gonna get this string ID, which is like a UUID for DynamoDB, and then use it to grab my taco. And then if I find something, I'll go ahead and pass in a 200, or I'll get a 404, right? And I have a delete taco as well, right? Same thing by ID. Getting an ID, and I'm deleting an actual taco. And then let's look at this tacos object. But this is kind of like my DAO for the sake of this talk. And again, a lot of this stuff gets injected with the serverless YAML configuration that I set up. Oh crap! Sorry, got it. Zoom in. But it's using some annotations for the DB stuff, for the DynamoDB things, creating the auto-generated key and so forth, and doing all the DynamoDB type of operations for me. Again, this would be some kind of DAO. If I was doing it the right way, I'd probably want to inject it somehow, use some kind of injection. I just did mine pretty simple for the sake of the demo. But behind the scenes is actually creating all this CloudFormation stuff for me and publishing all that. And like, if you look at everything that it spits out, like you'd have to write this by hand most of the time, but like the framework makes it pretty easy for you. So I tend to like it. I haven't run into many issues for the small things that I've been doing with it. My boss and I, we've used the serverless framework. My current job, we use serverless for a lot of for our Slack stuff to push out events when something's going on. If we commit code somewhere, it pushes out events to all these channels, depending on what the product is, and all the developers know, oh hey, we pushed out an update to this branch for this product, and that way, you know, all these other things happen, and the developers know. They either can have discussions about it or pull in the code or whatnot. We also do it for our pull request. Every time we submit a pull request, it publishes an event and gets pushed into our Slack channel and alerts all the developers that, hey, we have a pull request that needs to get reviewed. And it goes based on the actual product that we have. So we have 4 products. We have 4 channels. So each product has a channel, and we push pull requests to each specific product. And again, we did all that just using the serverless project to handle all that and push all that. So that's the code. What does it actually look like when you're using it? I'm going to go ahead here. So most of the times I would do a code deploy, right? But we're in here and kind of like a modern day chef. I already pushed out the code earlier because I was scared something would happen and something would go wrong. Let me see here if I can. Can you guys see that? Is that pretty small or pretty big? So I'm gonna do a simple get, and I did a curl. This is like the location to my API. Again, it's gonna take a while the first time because the actual Lambda function is not warmed up. It's kind of code, so it's gonna take a while, couple seconds. It's going through, loading up my code, and then execute, and boom, I get a JSON response of all the tacos, and it just has an ID, the taco type, and it has a price, right? Nothing fancy. We can then do a post. I think I had my post in here. I had a post in here. That's a simple post. It's going to go ahead and create this taco type. Again, the first time it runs, it's going to take a while. because there's not a function open. Boom, it created it. So now if I go do the get again, it actually comes back pretty fast, right? And here I have 2 potato and egg tacos. I'll delete one here in a minute. But again, it came back pretty fast because now I have a warmed up version of that function out there that I can execute on. And if I do it again, you know, it's pretty fast. And I'm going to create the same thing again. Let's see here. Different type of taco, like again, came back pretty fast because there's already a version of that called a get. Now I get my potato and chorizo taco that got put in there, right? The other thing that I wanted to show is I went ahead and I did the, if we wanted to, I think it suspended this. So can you guys, let me see here. No, that's not it. But I created this client, and let me see here if you guys can see it, because you probably want to.
I think we can see it fine.
Okay, I can tell. But basically, I created this Vue.js application. So I do Vue.js at my day job, and I created this like simple bootstrap thing. But I deployed this on S3, and again, if I wanted to, I mean, don't do this in real life because if it's on S3, it's not HTTPS. You need CloudFront and then upload your SSL certificate and all that. But for the sake of this thing, I just wanted to show you how easy it would be if you wanted to. And I have this Vue.js application on here, and if I refresh, now that my function's already loaded up, it loads up pretty fast. And if I wanted to create a new type of taco, we've got a beef pita taco, and beef is pretty expensive right now, so this taco is going to cost $6.50. We add it in there, boom, got added in. If I refresh, that taco is now part of the taco list. And we can start going through. So now I noticed I have a duplicate taco in here, and I can delete that. And of course, if I click on it the first time, like it's going to take a while because there's not a warmed up version of that Lambda function out there. So it was a cold start. So it took a while. But now if I go through and I delete this like beef fajita one, boom, like now it's pretty fast. And because there's a warmed up version of that function out there. Same thing for this one if I wanted to keep deleting and so forth. And I think this is pretty awesome because, again, like if you start running some of your applications like this, like you can have a very simple front end that's also serverless that you don't manage and you just push out your code to. In fact, you start to see a lot of that type of use cases. Is you start to see more people use something like called like the Jamstack. Netlify people do a lot of that stuff for you. There's various companies out there that are starting to get into that space, and you can use that with a serverless approach and use functions, something like AWS Lambda underneath the background. But yeah, so I'm pretty excited about this type of technology. Like I said, for the use cases, I mean, it saves you a ton on money. Like if you're not using it, you're not being charged for it. So you could have a bill of like just a couple pennies or nothing at all, depending if you didn't meet quota, or just a couple $100. There was one of the talks that I listened to from A Cloud Guru guys. Like the first couple of years, they weren't paying a single dime for compute because they were using AWS Lambda. Now they're paying, right? Because now they're having tons of requests. But early on, when the platform was getting started, they paid zero because they didn't meet their quotas when it came to the compute. They were paying the storage costs to store all the video and all the content, but the actual compute cost was very, very small. And you start to see a lot more companies starting to use, especially also in the enterprise. In fact, what gave me this idea to use the Vue.js on S3 was a talk that I had seen from Capital One. And in Capital One, they had taken one of their products, one of their widely used products that they had, and it was running on some kind of, I think it was like Nginx type of scenario web server, and then it was using some microservices in the background. But they moved it to run on S3 on an S3 bucket, and then was talking to AWS Lambda, and they deployed it, and it worked great for their use case, and it saved them a ton of money. They weren't spending that much on the actual cost to actually use the service, and then also the operational overhead of having to manage all the server instances, having to manage the Nginx instances, and so forth. Everything just worked. So yeah, and a couple of my buddies at a consulting place that I was at have started using this approach. They were telling me that one of the headaches that they have is they've had a little bit of DevOps issues and making sure the way they set up their continuous integration pipeline. And I think there's still a lot of work to be done in that space, which is why I think serverless is utilizing has their product that's going their product that they're actually charging for. And GameStop here in DFW ran into the same problem, and they developed an internal solution for it so that they could go into the different environments and go along the CI/CD process. And they called it had a weird name. They called it Mother Hen. I don't know if like somebody over there was like really into chickens, was a chicken farmer. I don't know. It's called Mother Hen, but it was basically to help solve their CI/CD issues that they had. So yeah, that's pretty much it. That's all I have for now. Again, thank you for your time. If you guys have any comments or anything, I'm gonna post a quick in the chat. If somebody, let's see here, I have a Google form out there. If you guys could, I'm just soliciting some feedback. This is only like the second time that I've given this talk, and it's a talk that I've been working on for a while, and so I'm looking for feedback and ways to improve it. Something that you guys want to see that maybe you felt I didn't cover, or I also have some questions in there for possible follow-ups to this talk. Like I said, I do want to do one eventually on Quarkus and Micronaut to show maybe how much faster it is, as far as like how much it minimizes the cold start time, and the DynamoDB as well, because I think DynamoDB is a pretty interesting technology. But thank you guys for that time and for the great questions.
Thank you, Andrew. Doesn't look like we have any questions right now. I guess I just want to say our next Java user group meetup is on September 10th, and it features Venkat. And I'd say goodbye. Yeah, because hold on, before I leave, I just want to say Venkat. Like, man, Venkat is such a great speaker. Like, I'm sure all of you guys have seen Venkat. Like, everybody has seen Venkat, like, numerous times. And whenever he comes through Dallas, like, all my friends that hardly ever go to user groups, I tell them, like, you guys are going to want to stop, like, whatever you guys are doing, go attend this talk. Because Venkat is an amazing speaker. I don't know how that guy does it, but he drops these, like, nuggets of knowledge. And I'll definitely be on for that one. Yeah. Please do. Yeah. All right. All right. Thanks, Justin. Thanks, guys. Guys, have a good one. You too. Bye. Thank you.